Good day, ladies and gentlemen. Thank you for the opportunity to share with you the work we've been doing on the production of metal sheets by direct powder rolling. My name is Dr. Silethelwe Chikosha. I am part of the Powder Metallurgy Technologies Group, which is part of the Advanced Materials and Engineering Impact Area at the Manufacturing Cluster. Today I will take you through the work that we've done in developing the direct powder rolling by explaining the objective of the work, give you the background as to how it started, explain to you the direct powder rolling process itself, show you what the primary product look like, and I'll also show you the properties of the primary products that we're able to get. I will also show you some of the secondary products that we produced, and then I will explain to you what next and how you can get involved. In terms of the objective, this work was initiated by the Department of Science and Innovation. The intention was to beneficiate South African mineral resources. Specifically with titanium was to also create a South African titanium industry. And this involved that you look at the whole value chain of titanium from its extraction all the way to producing semi-finished and finished products. And if you look at the diagram below, it shows you the value chain of titanium, and on the vertical side of the diagram you will see that it talks about the extraction of titanium, and the product that you get is titanium powder, which was the intended product for this particular project. And on the horizontal end it talks about the development that we had to do to get to make semi-finished and finished products, and the different processes that we use to make specific products. In the list of the specific products, direct powder rolling, which is highlighted in orange, is the process that we're going to talk about today. This is a process that can be used to convert titanium powder into sheets. And these sheets can be used in different application areas such as aerospace, the chemical industry, and so on. Just before we talk about the direct powder rolling itself, I will explain to you a bit of how the process of making titanium currently is done. You will see that this starts with the process of extracting the titanium from illuminite, which is an oxide. And what you get out of that process is a sponge, which is a coarse form of a powder. This sponge is then consolidated and melted to give you what we call an ingot. Hence the process is called ingot metallurgy or wrought metallurgy. So this ingot now is a very big ingot that you now have to break down to get to your sheets. And two types of sheets you will be able to get out of here, which is coils, which are kilometers long type of sheets, and then the other sheets is when you cut the coils to get specific sizes of sheets that are required by the end user. The process also shows other products that you can make out of this ingot metallurgy process, such as the forgings, the bars, and the blades. But for today we will focus on the process of making sheets. Something to highlight is the expense that comes with processing of titanium falls in the first leg, which is the extraction, because titanium likes oxygen and typically it's difficult to extract it into pure metal from the oxygen. And then the second stage is the melting of the process of the titanium, and then after that you have to go through several hot rolling stages to reduce the ingot down, and then you do several other cold rolling stages to get into sheets. And then once you have these sheets, you also have to anneal them in a high vacuum environment to minimize oxygen when you produce your product. And all these processes contribute to the cost associated with the production of titanium. Hence, it is expensive, and hence it is necessary that we develop a process that can produce titanium at a very reduced cost. And we expect that if this succeeds, then we are able to open up other opportunities that can use titanium, because now it will be affordable. With the intended production of titanium powder, it was necessary then that the process that we use is able to convert powder into sheets. And in this case, we evaluated a process called direct powder rolling. Direct powder rolling will convert your powder, which is what you will receive as your feedstock, and you will roll it in horizontally aligned rolls, and what you will get out is what we call green sheets, which is sheets that are produced by mechanical bonding of the powders. Then you'll cut these into sizes that fit into a furnace, and then you'll put them in a furnace to sinter them. The process of sintering gives you a metallurgical bond, so that when you hold these sheets, they are not easily broken. And then when you are done with the sintering process, you go through the stage of re-rolling the strips just to increase the densification, but also to optimize the properties of the sheets. And then you take the sheets back into the furnace and anneal them. And what you get out at that stage will be your final product, which is the sheets. The processed products look as shown here. What you have on the left-hand side is your powder that you use as the feedstock. And what you can do now is when you roll it down, you can do different sizes as illustrated in the middle picture. And these, as I have mentioned, are called green strips, and the green strips are very fragile. They are mechanically bonded and they will easily break. And then when you take these sheets through to sintering, re-rolling and annealing, what you get is your final product, which is your sintered strip. And this strip is now very hard, and you cannot break it with your bare hands. And that is the final product that you get out of the process of direct powder rolling. The CSIR has granted this process a technology readiness level 6, which means that if it is upscaled, you can consider now taking it for manufacturing, or you take it for commercialization. And also South Africa granted it a patent to show that the process is a viable process. In terms of the products that come out from this process, you can make several grades of titanium. Titanium has titanium grade 1, grade 2, grade 3, grade 4, and grade 5. And to date, we have been able to demonstrate this process for titanium grade 2, grade 3, and grade 4 in a lab scale. And in order to check that our titanium is within acceptable specifications on a global or international scale, we check them against global standards, for instance, the ASTM standard. But also we do check that against other commercial suppliers who are making this product with the current ingot metallurgy process. And what I am showing here is the properties, the critical properties for you to be able to say that you have produced a good quality product. And in this case, I'm only going to show titanium grade 2 and the properties that we got. The first property to think about is the yield strength, which is the point at which your material starts to permanently deform, and then your tensile strength, which is the highest strength that your titanium can withstand, and finally the elongation, which is the ductility that you get when you deform your titanium before it actually breaks. And finally, it is very critical that you maintain a certain composition for the titanium, and specifically with titanium, the grading is dependent on oxygen, so it becomes one of the critical markers that you must get right to be able to say that your product is a specific grade. And also I will show you the microstructure, the typical microstructure that you get out of these products. And we can see from the results that in terms of the standards, the yield strength is between 275 and 450, and the product from a supplier was 335, and the CSIR titanium grade 2 was 344 megapascals. And this shows that this titanium is within the international specifications for yield strength. The next property is also your tensile strength, of which the minimum you must achieve for this grade is 345 megapascals. And our other supplier was able to achieve a 420, and the CSIR grade is 463. In terms of the elongation, the minimum you must achieve is 20%, and the supplier's product was 35%, the CSIR product was 29%. It is clear from these results that the CSIR product is within the specifications that are internationally acceptable for this grade. And then in terms of the oxygen, the maximum that is allowed is 0.25% for a titanium grade 2. And the CSIR titanium product was 0.22%, which is within the specifications. And if you look at the microstructure of this titanium, you will see that you get what we call equiexed grains, and these grains are typical of titanium products, and it does not show any effects of rolling, which was eliminated by the process of annealing. And this also matches what you will typically get from other suppliers and from the international standards. In terms of the secondary products, we were also able to do a few other products. In this case, what you see on your left hand side is a letter opener that we were able to produce out of the CSIR produced titanium sheets, and on the right hand side what you see is a washer that was also produced out of the titanium sheets produced at CSIR. There are several other products that can be made out of this and out of these titanium sheets, but we only show the two that we have produced to date. In terms of then what happens next, or what else can direct powder rolling do, for some of you who may be sitting there and thinking, but you only did this for titanium, what else can it do? I think if you have a process and a product that is expensive to manufacture in the form of sheets, this is a process that you can consider to use. And then if you are dealing with hard materials such as aluminides and composites, which are metal oxides, metal carbides, metal nitrides, these are all materials that can also be evaluated and produced by the direct powder rolling process. In summary, overall, what you want to do is to include difficult to work. If you have any material or metal out there that is very difficult to work, meaning it's hard to deform, this will be a product to consider, because direct powder rolling does not require a lot of deformation to get to your final product. In terms of what next then and how you can get involved, what we are doing now is the development of this process, extending it beyond titanium to materials similar to the ones that I have described in the previous slide. Also, we are doing techno-economic studies and the scalability of the process. We are running these parallel in order to be able to determine if this process can be scaled in to give sufficient product size and quantity to compete with the current process of making titanium. At the same time, to evaluate if once scaled to a commercial size, it will be still a techno-economically viable process to be able to commercialize it. And in terms of getting involved, we can participate in partnerships and collaborations in the 3 areas that I have highlighted above, such as development of other materials, techno-economic studies, and scalability. And thank you for the opportunity to listen to this work. And at this stage, we will take any questions that you may have.